50 on 179. So we have 2x to 2/3 plus 7x to 1/3 minus 15 equals 0. Solve the equation. So I'm going to say let y be the one with a smaller power. Only if this, when I square both sides, I get y squared, which is indeed x to 2/3. Only if this one is y squared. So this equation is not quadratic, but quadratic in form, we say. So this is 2y squared plus 7y minus 15 equals 0. Is this clear?
No,
Which part?
the whole thing. Wait, okay. So I see that making x 1/3
To power 1/3.
Power 1/3.
Yes.
And y squared equals x.
So if y is considered to be x to 1/3, then when you square both sides, you get y squared on one side and x to 2/3 on the other. Because you copy the base and multiply the exponents. 1/3 times 2/1 is 2/3.
Okay.
Therefore, the equation can be converted into this quadratic one. And now nobody tells me what to do. I can choose the method I want. If you want to use the quadratic formula, you can use the quadratic formula. You don't have to factor if you don't want to. So, but if you factor, this is a negative 30, and that's positive 7. And that's 10 and 3, if you want to factor. So this is 2y squared plus 10y minus 3y minus 15 equals 0. I factor out 2y, and I get y plus 5. I have to get a y plus 5 from the other two, and I have a negative 3. So therefore, y plus 5 and 2y minus 3 equals 0. So I have y equals negative 5 and y equals 3/2. This is good, but it's not good enough because I have to go back to x. So now this equation is actually x to 1/3 equals negative 5. X to 1/3 equals negative 5. But I know what x to 1/3 is nothing else but the cube root of x. So in order to find a solution, I have to cube both sides. So from here, x equals negative 125. The same thing with the other one. Now I have x to 1/3 equals 3/2. But x to 1/3 is nothing else but the cube root of x equals 3/2, so I have to cube both sides. So the left-hand side is x, the right-hand side is 27/8. If you remember, every time we raise both sides to a power, we have to check the solution. I don't know, I don't guarantee that it works. But if you plug it in, you will get the cube root of negative 125, which is indeed 5. So this works. And when I plug in here, the cube root of 27/8 is indeed 3/2. So both solutions work. Now this is a difficult problem. I don't consider this a trivial problem. Because first of all, you have to realize that this multiplied by 2 is this. Secondly, you have to say, well, what if I denote this by y, right? Is this y squared? Yes, it happens that it is. So then it's quadratic in form. This equation is not quadratic, but it can be changed into a quadratic. So we say it's quadratic in form. And this was nice because once I changed it into a quadratic equation, everything went smoothly till I got here, and now I have two equations. One y, which is x to 1/3, x to 1/3 equals negative 5, and x to 1/3 equals 3/2. It would have been more difficult to factor it as is. Do I have to use a substitution? No. No, but it would have been somewhat more difficult to factor this into the cube root of x plus 5 times 2 the cube root of x minus 3, because that's what it is. the cube root of x plus 5 times 2 the cube root of x minus 3 equals 0. So this was substitution. Is that okay? Better? Now you have some problems to practice with, and they have solutions in the back. So, for example, 49 was recommended, 51 was recommended, and you have solutions in the back of the book. Do you think we need to do one more, or are we okay? Because I would like to get to as many topics as possible.
That's fine for me.
Yeah? Okay, at the end, remind me and I'll do one more, but I'd like to move on to other topics, and I'll come back. So the other topic was the difference quotient. So give me any function you want. Quadratic, radical, rational. Let's say a quadratic, which is common, right? So let's say negative 3x squared plus 2x minus 7. And the difference quotient formula will be given to you. I'm not expecting you to remember that. In calculus, we have to know it by heart. So this is f of x plus h minus f of x divided by h. Okay? So this piece and this piece are clear, but this one is not. It needs work. So I have to find f of x plus h. You will remember these things. If you go through your test 3 or 4 times, you will remember them. They are still somewhere. Trust me, because you've seen this. So how do I determine f of x plus h? Good. So now I have to remember something very important, that we made a contract on this a long time ago. How many terms will I have to write? Yes. So it's negative 3, and then it's x squared plus 2xh plus h squared plus 2x plus 2h minus 7. And this is negative 3x squared minus 6xh minus 3h squared plus 2x plus 2h minus 7. So now from here, I have continue here, plugging in what I just found for f of x plus h. So all that is this right here. So I'm going to copy it. Negative 3x squared minus 6xh minus 3h squared plus 2x plus 2h minus 7. Now I reach this minus, so I have to change all signs that follow to plus 3x squared minus 2x and plus 7. So now I know that all terms without h must go away. So negative 3x squared with positive 3x squared, positive 2x with negative 2x, and negative 7, positive 7. Other terms may go away as well, but at least those terms with no x must go away. So now we have 1, 2, 3 terms left, and all of them have h in common, and I have to factor it out. Why? Because I will eventually simplify it with the h in the denominator. So I have negative 6x, I have negative 3h, and I have positive 2. So the simplified form is negative 6x minus 3h and plus 2. Now, as I said, I did not put a trig equation on this, but you will have a trig equation on the test, on the final. So I'm trying to find those. They are in chapter 6. 6.5, if I remember correctly. Yes, 6.5 on page. We solved several of them. So let's do 24. On page 694. And that was 7 cosine theta plus 9 equals negative 2 cosine theta. First, I have to solve for cosine theta. So I will move this here, and I will move this here. So when I bring a positive 2 cosine theta to 7 cosine theta, I have 9 cosine theta. And then I subtract 9. I do divide both sides by 9, so I have cosine theta equals negative 1. And that's the reason why in one of the problems on the test, I asked you to find cosine 0, 90, 180, 270, and 360. So now I know, I'm thinking, where is cosine negative 1? Cosine is measured on the x-axis. So where will be negative 1? Exactly. So the answer is pi plus 2 pi k. Because there is only one point on the unit circle where cosine is negative 1. There are no two options. Yes, infinitely many options because of k. Infinitely many solutions because of k, but only one option, basically. What was the other topic we said? There were 4 topics.
Piecewise.
Oh, yes. Back to chapter 2, I believe, if I remember correctly. Yes. On page 240. Let's do 54. Actually, on 241. Where we have a function, it's a piecewise defined function given with 3 pieces. Okay, what do I have to determine when I'm asked, first, when I'm asked to graph a function? Very good. So I have to look at this, and I will say negative infinity to negative 3. I will look at this, and I'll say negative 3 with a bracket, comma, 0 with a parenthesis. And when I look at this, I see 0 bracket to infinity. Now I can identify the domain. Can anyone tell us what is the domain of this function? Of course, nothing is missing, right? Negative infinity to negative 3, including negative 3 and 0, including 0 and infinity. Exactly. All these numbers, like negative 3 and 0, have to be in the chart. So negative 3 and 0. They are key points. Now, if you use my method, then you will put a parenthesis facing to left and a bracket facing right under and touching negative 3. The same thing, parenthesis and bracket under 0, and they are touching. When will they not touch? When I'm given a particular number, like f of x is 5, when x is 2. Bless you, and then they will not touch. Okay, I know this is an overkill, but I will write 0 here. I will write negative x here, and I will write x squared minus 1 here. And then I'll say negative 4, 0. Negative 3, 0. Negative 3, 3. 0, 0. 0, negative 1. 1, 0. I have to keep in mind that this is linear, but this is quadratic. Good. So negative 4 0. Negative 3 0. Open. Negative 3 3. Full point. 0 0. Open point. Linear function with a negative slope. 0, -1, full point. 1, 0, full point, of course, opening up. Because I know how to graph this, right? From transformations, I know that this is x squared. And where will I graph x squared minus 1? Down 1. But I cannot graph the entire graph because x squared minus 1 is only between 0 and infinity. I cannot continue here. That would be a terrible mistake to do that. So this is the graph of f of x. Now if I ask, what about the range? What is the range of this function? Very good. Any questions? So let's go back for a second to that second test. So these were some transformations. Then we had finding the sum and the difference, product, ratio, and the domains. Then we looked at the function was one-to-one and find its inverse. Find the equation of a circle. And graph whether, or show whether they are inverses of each other. Any of these topics?
Will the equation of a circle, will that be given to us?
You mean the x minus a h? No, but if you forget it, I'll tell you. But it's the same with the equation of the distance, the formula for the distance between 2 points. Yes, Eduardo, you wanted to say something?
Can we do the inverse of each other?
Yes, very good. So we are given two functions, f of x equals 2x plus 3, and g of x equals x minus 2 over 4. Use the property of inverse functions to determine whether the functions are inverses of each other. If you remember, what I have to show is this. So these are the functions, and in order to show that they are inverses of each other, I'm asked to use the property of inverse functions. So if I can show that f comma g is x, in other words, these two functions cancel their effect on x. So I apply g and then f, nothing happens. It's a washout, right? Nothing. If I apply f first and then g, nothing happens. I get back x that I started with. Then the functions are inverses of each other. So let's find f comma g. F comma g of x is f of g of x by definition, which is f of x minus 2 over 4. And now I have to look at f. F says 2 times whatever plus 3. Now whatever is x minus 2 over 4. So how do I present 2 times whatever plus 3? 2 times x minus 2 over 4 plus 3. But when I try to simplify, I get that x minus 2 over 2 plus 3. I multiply the top by 2. So it's x minus 2 plus 6 divided by 2, which is x plus 4 divided by 2. But this does not equal x. This is x plus 4 over 2. It's not x. So what do I conclude? And I will not even need to determine the other one. Not inverses of each other. So when I applied the g first and then f, I got something else. I did not get my x back.
So you're supposed to get x, right?
Yes. It's like, for example, I give you $10 and I take it back. No deal. That's why adding 10 and subtracting 10 are inverse operations. Okay, back to anything else from test 2. Let's look one more time, and we'll come back. Equation of the circle, finding the inverse of a function, sum and difference, product and ratio, transformations, average rate of a function, average rate of change of a function between 2 points, A line passes through a point and is perpendicular to a line. Find the equation of the line. We already looked at the difference quotient. We already looked at the piecewise defined function. Is the function symmetric, odd or even?
Can we do that one?
Yes. So f of x equals 5x cubed minus 6x to the fifth. Remember, in both cases, I have to determine f of negative x. So that will be 5 times negative x to the third minus 6 times negative x to the fifth. Negative x to the third is negative x to the third times 5 will be negative 5x to the third. Negative x to the fifth is negative x to the fifth times negative 6 is positive 6x to the fifth. So now I have to answer yes to one of these three questions. Only to one. Does this equal f of x? Does it equal negative f of x? Or none of the above? So I have to say yes to only one of these three. So is this identical with f of x? Is this identical with f of x? No. Is this identical with the opposite of f of x? In other words, if I put negative here, this changes into negative, and this changes into positive. Now, is negative f of x identical with this? Yes. So I will say yes, and I will cross out the third one. Therefore, the function is symmetric with respect to the origin. It's an odd function, symmetric with respect to the origin. Okay, back. Reading from the graph. When x is 3, I want to determine y. Finding x and y intercepts. Finding the intervals on which the function is increasing or decreasing. Does this equation define y as a function of x? I have to solve for y, and when I solve for y, I put plus or minus. So to 1x, I'll get two different y values. That's why it's not. Any of this? Okay, let's look at the third test. Quadratic function, we're asked to find the maximum profit. How do I find the maximum of a quadratic function? Negative b over 2a. So x equals negative b over 2a, and then the answer is plugged back in. This is valid only for quadratic functions. Only quadratic functions have a vertex. Okay? Let me know. Expand the following expression using the properties of log. Log of a ratio, log of a product, and log of a power.
Can we do that one?
Of course. Log base 2 of x, the square root of x minus 1, divided by 3x plus 4. We only have three rules. Let me remind you the rules. Log of a multiplied by b. Log of a divided by b. Or log of a raised to a power, let's say x. We do not have log of a plus b. It doesn't exist. We do not have log of a minus b. We cannot simplify those. We can only simplify a product, a ratio, or a power. Only these three. So I have to start with a ratio. So then I will say log base 2 of x, the square root of x minus 1, minus log in parentheses 3x plus 4. So I use this property. Log of the top minus log of the bottom. So this is done. There are no more ratios in my problem. Then I continue and I see a product. The product rule requires sum. I have to write sum. Log base 2 of x and plus log base 2 of the square root of x minus 1 and minus log 3x plus 4. There are no more products in the problem, and I exhausted the other rule as well. This is completely simplified. Nobody can further simplify it. This is completely simplified. Nobody can further simplify it. However, this can be further simplified because I have one more rule that I can apply. Because yes, x minus 1 is raised to power 1/2 if I look at the square root, right? The square root means power 1/2. So if you want to rewrite it, you can. Log base 2 of x plus log base 2 of x minus 1 raised to power 1/2. This is the same thing with the square root, right? Okay. And then minus log 3x plus 4. So the only thing is I have to use this power rule where the power becomes a factor, which means multiplies log. So that would be, yes.
So you don't have to put log base 2 for the second part of all, you're just putting log, okay.
Sorry. Absolutely. I will not be able to go back.
Right.
If they have different bases, then what I did is false. So x minus 1 minus log base 2 and 3x plus 4. So this is the simplified form of that log applied to a complex expression. Any questions? Okay. Graphing a polynomial function. Multiplicities, turns and crosses, crossing flat, turning flat. Let me know. Solve the equations.
Yes, please.
Okay. This is a tough one, in my opinion. It's not a trivial. So 2 raised to x minus 2 equals 3 raised to 3x plus 5. However, on the first 2 tests, you did exceptionally well as a group. Exceptionally well. Okay. Now this is tough. Why is it tough? Because 2 and 3 cannot be presented with the same base. So my only hope is, or chance is, to solve this is by applying log or common log or natural log to both sides. I'm using this property now. I'm bringing the power in front as a factor. So I have x minus 2 in parentheses, log 2 equals 3 plus x in parentheses, log 3. Now, if you notice this, from this point on, it should not be difficult. I know when you look at log 2, you feel like, oh, wow, what is that? It's just a simple number. And all you have to do is take this number and distribute it to x and distribute it to negative 2. The same thing with log 3. So x log 2 minus 2 log 2 equals 3x log 3 plus 5 log 3. Now I notice this is a linear equation. It has sophisticated numbers in it, but they're simple numbers, nothing else. So this and this have to be on the same side because they contain x. This one has to go to the other side. So I have x log 2 minus 3x log 3 equals 2 log 2 plus 5 log 3. Again, don't look at this. This is just a bunch of numbers, nothing else. But here on this side, I cannot combine them. What should I do in order to get x by itself eventually? Factor, I'll pull out the x. So I have log 2 minus 3 log 3 equals 2 log 2 plus 5 log 3. It's a lot of writing, but they are just numbers. So then x equals, of course I have to divide this number by the number that multiplies x. So 2 log 2 plus 5 log 3 log 2 minus 3 log 3. Now if you want to check this, you can. You have to put this in the graphing calculator, get an approximation, and then plug it in to see that you get both sides to be equal. Any questions? Okay. Now this is a log equation. Let me know. Yes, no? Okay. Now this is a easier, although it looks awful, it's an easier exponential equation. Why? Because both sides can be presented with the same base. So the left-hand side will be 2 squared, and the right-hand side will be 2 raised to negative 5. Because it's a fraction. 32 is 2 to the 5th. 1 over 2 to the 5th is 2 to negative 5. Let me know if we need any of these two.
We do C.
Yes? If you redo your tests 3 times or so, you should be fine. You should have no difficulties on the final. I'm not going to invent anything, of course. Okay, 4 to 2x minus 1 equals 1 over 32 to 2 minus x. Can you use log? Yes. I don't recommend it. It's easier than that. So I know that 4 can be presented as 2 squared raised to 2x minus 1. Now I hope you agree that 32 is 2 to the 5th. Oops. And 1 over 32 is 1 over 2 to the 5th, which is 2 to negative 5. We agree on that? So then the right-hand side is 2 to negative 5, everything raised to 2 minus x. Since both sides have the same base, I will copy the base, and what do I do with the exponents? Right, so I have 4x minus 2. I copy the base, what do I do with the exponents? Right, negative 10 plus 5x. Now, I don't want you to cross out x or 2. I'm not doing that. Okay, I'm saying this. 2 numbers are equal, and they have the same base. What has to happen to their exponents then? They must equal each other. So then 4x minus 2 must equal negative 10 plus 5x. I move negative 5x, I get negative x, and I move negative 2, and I get negative 8, so x equals 8. Any questions? Is this okay? Better? Okay. Let's see what else is here. Inequalities.
Yes, can you do A or B? I don't care.
Yeah, let's do both. You should have no difficulties with this because if you use the chart that I showed you, should not be any problem, I hope. So negative x minus 3 divided by x minus 2 less than 0. It's chart ready because I have a ratio or a product, on one side and 0 on the other. So then if you use the chart, you don't have to. I accept any method. X is the variable in the problem. I have to find the values that make these quantities 0. So I take the numerator, negative x minus 3 equals 0, negative x equals 3, x equals negative 3. So negative 3 is one value that I need to put in the chart. And the other one is 2. So negative 3 and 2. There is a 0 for negative x minus 3, and there is a 0 for 2. And now what happens when the numerator of a fraction is 0? The fraction is 0. What happens when the denominator of the fraction is 0? Careful. Undefined. That's why I cannot put a number in there. I just put undefined, right? Now, this is a linear function with a negative slope, which does this. It comes from positive and goes negative. So, or you plug in a number. It's up to you. This one, though, it looks like this. It's coming from negative and going positive. So it's negative, 0, and then positive. On this interval negative, on this subinterval positive, on this subinterval negative. And now I choose what I'm asked to. And I know that only negative sign is less than 0. So I have to choose negative, which means I have to choose this, and I have to choose this. So then x in the interval, negative infinity and negative 3, union to infinity. Now, what we're doing now should make your life easier at home when you redo those tests. Okay, let's go back. Oh, we want the other one too.
That was good enough,
Okay,
at least for me. Somebody else wants it.
okay. Find the domain and present it in interval notation. Log is a function with problems, like a square root. I cannot apply log to a negative number or 0. So 2 minus x must be greater than 0.
Can we do that one?
Sure. 2, so log. So this is f of x, which is log base, just log, I'm sorry. 2 minus x. 2 minus x must be greater than 0. Negative x greater than negative 2. X less than 2. Domain, negative infinity, 2. Log is applied to 2 minus x. 2 minus x must be positive. This is a function, it's exponential, and we're asked a few things about it. Yes, no? First few are just plugging in. If you want to do E, we can. After how many weeks does the percentage drop to 50%? So f of x is the percentage. 80 e to negative 0.5 x plus 20. We're asked after how many weeks the percentage is 50. Yes or no? We want to work on this part?
Oh, yes.
Yes? Okay. Good. So,
The last question of that one.
sure. Yes. So then 50 equals 80 e to negative 0.5x plus 20. First step. Good. So then I have 30 equals 80 e to negative 0.5x. Next step, mandatory step actually. Divide by 80. 3 over 8 equals e to negative 0.5x. Now what? Because I cannot make the left and the right with the same base. I have to apply natural log. So then natural log of 3 over 8 equals negative 0.5x. So then x equals natural log 3 over 8 over negative 0.5. How much? Okay, x approximately 2 weeks. Any questions? Any questions? Okay, so back to the rest. Same thing, we're given the exponential growth model. T is a number of years after 2000 to find the exponential function that models the data. In other words, I have to find a 0 and k. And then another question. And then graphic and exponential function. And 3 questions on this function, the logistic function. We didn't study it, in detail, but it's a function that has exponentials in it. And then graphing a rational function. And that's it. I think this was extra credit. Okay, let's go back and see if we need anything from here. Rational.
How about number 8?
Good. So we are given that in the year 2000, population was 6.04 million. And in 2050, projected to grow to 10 million. Okay. Use the exponential growth model, which is given to us. A of t equals a0 e to kt, in which t is the number of years after 2000, which means t equals 0 represents the year 2000. And find an exponential function that models the data. In other words, find a0 and k.